Hey, so welcome everybody to this next session of Remep. So we are now at the roundtable that is chaired by Professor Giovanni Sartor on the topic of computational law in practice. And for this roundtable, he will be joined by Michael Geneserth, Burkhard Schafer, and Professor Prof. Kowalski. And it is my pleasure now to first introduce to you Professor Giovanni Sartor, who will be chairing this session. And he's a professor at the University of Bologna and at the European University Institute in Florence, and has recently received an ERC grant on CompuLaw. As you probably know, the ERC grants are the top grants that you can get in the European Union. That's the highest achievement that you can get as a researcher here. And besides that, he was also the president of the International Association of Artificial Intelligence and Law, is one of the top experts in this area. And we are very glad that he's here and joining Remep. And I may now hand over to him. So please, Professor Sartor, the floor is yours.
Okay, thank you very much for this introduction. I'm very happy to be here. And in particular, I'm very happy to chair this panel with so distinguished speakers and friends. Before moving into the panel and introducing the participants, I have been asked to make a short introduction to my ERC project. So this it will not last more than 5 minutes. So let me share the screen, and I hope it works. Share. Okay. Now you should see the screen on my computer, and I go quickly with my short presentation of sorry, this is not the first slide of the CompuLaw project. I hope it works and that you are seeing the right screen. Otherwise, I should swap displays. Are you seeing the right screen? Yes. Okay. Perfect. So
you need to
swap. Okay, let me swap displays. Okay, now it should be better. Okay, let me go with the CompuLaw project. It is the issue that CompuLaw aims to address is the same issue that was addressed by Professor Geneserth, but the focus is on more on machine compliance with the law rather than on human being helped by machines in complying with the law. So the idea is that we are entering an era where computation are everywhere. It is impossible to monitor them real time. And so we need to find a way to have legally compliant computational processes. And the idea is to consider making the law computable as an internal component of computational processes, which means that we need to have computable representations of legal information and reasoning that are processed by computational entities, by agents. So the focus on the project is of moving from implicit law by design, so building system in such a way that unlawful behavior is more difficult, in particular to security measures, or also to the idea of original idea of privacy by design was in this direction. Moving into explicit law by design, I would say, so systems that represent the law explicitly and operate effectively on the basis of this knowledge. And so this is the problem. There are many challenges to be made in order to build artificial legal agents being capable and motivated to comply with the norms that apply to their own behavior. Consider autonomous vehicles, which have obviously to comply with street codes, as Professor Geneserth mentioned, but also online shoppers or other agents engaging in online business, online trading, who have to make contracts and enter other legal transactions. So there is the need to keep human control over the design of such rules and also over the way in which they are applied, even though it is not possible to have a real-time check. There is a need of crucial issues that I will try to address to my project. Now the second year has been completed, and we are moving on with the further development. The complex theoretical background, which merges computer science, law, and also aspects of ethics and philosophy. I must say that this project is in a synergetic relation with other projects that are going on in Bologna at our Center for Computers and Law, and now a part of the Bologna Center for Artificial Intelligence, which is called ALMA AI. And let me just mention that some work has already been done. You can find that on the some of this work on the website of the Compulo projects. We have many analyses of legal issues of AI and of the legal issues involved in making legal and ethical issues involved in making the law computable. I have made in these years some studies on legal interpretation and building formal models of it that have gone into a book that has been published with Professor Walton and Macagno. Then we did quite some work on legal argumentation. Some papers can be found on ICAIL, and some new work is coming on burdens and standards of proof, how to provide formal models of that, and also reasoning about preferences. There is also some work on reasoning with values and principles. Also there is some paper at, there is a paper also at ICAIL and URIX. There is some new work on deontic logic. I think that deontic logic is a bit a weak point of computational law because currently available deontic logic have problems, but I believe that these problems can be solved, and I've been working in the two directions on the ceteris paribus semantics and also on a causal semantic for deontic logic, and I'm hopefully something will come out of that. Some work also on causality and probability of the law. We have already an advisory system dealing with unfair clauses in contracts. This is not based on a logical representation, but on natural language processing and machine learning. You can find the link to the website. This is a parallel project, but there is a partial merge overlap with Compulo. We are building an online system for legal argumentation. There is also some online work on modeling contracts for blockchain applications. We have working on how to extract legal knowledge from cases, and also on two prototypes dealing with compliance by autonomous cars and online shopping agents. I think I stop here. Sorry, here you can see also the link where you can find information on the project, which merges aspect of legal theory, logic, philosophy, and computing. And I think I stop here with my presentation because I look forward to the to our roundtable. So without further ado, I would like to introduce the participants in this roundtable that are with us today. I think I should stop screen sharing. Sorry, stop share. Okay, that are with us today. We have three illustrious participants. We have, first of all, Professor Geneserth. It was already presented. And we all know his work, so I will not add any work on him, only that his work and his center as an inspiration for everybody working on computable law. Professor Kowalski doesn't need any presentation. He was leading research on prologue and logic programming for many years, developing many breakthroughs, I think, in computer science. from his work on logic programming to the event calculus to his recent work on argumentation. And also his even more recent work on how to program using an English-like language. Bob Kowalski has been an inspiration for everybody working in the domain of computable law. Professor Geneserth mentioned his work, his and his group work on the British Nationality Act, which opened the research on logic programming in the law. So I'm very happy he has received a number of prizes and recognitions everywhere. So I will not mention them because they are really too many. I moved to Burkhard Schafer, who has been working in the domain of AI and law for many years, and merging legal issues and the issues of building computable models. He's working at the University of now currently of Edinburgh, and he played a leading role in various domains of the law and the interaction between computable law and issues concerning to evidence, criminal responsibility, proof, IP law, and other domains as forensic research and other domains as well. So I would like to stop now, and I am very happy now to give the floor to the participants in the roundtable. So who shall start? Maybe shall we start with Robert, and then Burkhard, and then Professor Geneserth? Is it okay if we follow this order? Robert, do you want to start? Professor Kowalski? We cannot hear you, Robert. I think you're muted.
You can hear me now, I hope.
Yes, perfect.
Yeah,
thanks
great. Okay, so I wanted to thank you for such a generous and kind introduction, and launch straight ahead into some points that were provoked by Michael's excellent presentation. And let me preface my remark by saying that I was head of Department of Computing for 2 years, and I encountered, well, first of all, I wanted to create, as head of department, a new approach, which was to make decisions by rules and to treat my friends and my not such friendly people in the same way. And I had ideas about computing workloads and making sure that everybody had the same workload, taking into account their teaching and their research and the income they brought into the department. And I thought that this would be welcomed by the department, but in fact, far from it. People didn't like rules. They much preferred to exercise negotiation and argumentation skills that they developed over the years. A bit like Hammurabi, the strong wanted to maintain their sway over the weak. And I ultimately retired from my headship of department after 2 of the 5 years I had originally agreed to serve. And in fact, over the years, I've encountered a lot of resistance to rule-based reasoning and rule-based approaches to leading one's life. I mean, libertarian politicians and advocates of libertarian approaches, people who don't want to be vaccinated, people who want to carry guns, people who don't want to be told what to do. There are a lot of such people, and it seems to me that the rule-based approach that some of us advocate has a political side to it. And I wonder whether we should acknowledge that. And I have other things to say. I mean, I want to talk about ambiguity and vagueness and open texture, but I'd like to throw this question open. I mean, and in particular, I'd like to mention that when we did our work on the British Nationality Act, we were subject to enormous criticism. The newspapers were full of political arguments against our work, saying that any work that might be of use to the government would obviously be directed against the people. So it seems to me that it's very hard to disentangle work on computational law from political positions. And it may be that ultimately this is one of the problems that we need to worry about. I mean, take regulation and deregulation in the financial world. Companies, many of them at least, would prefer to be deregulated, to have fewer regulations and not more regulations. So how do we take a stand on that? Or are we neutral? I mean, logic, academic, science, we ought to be in some sense neutral, but are we? Maybe, ethically speaking, we're taking a position on one side of the political divide. So I wanted to throw that open rather than go on to my next topic of ambiguity and open texture. Michael?
Yeah. So
Giovanni?
Hello. Yes.
Okay.
So I'd like to at least respond to a couple of those points. I don't know if there's a red light that I would like to, I value the idea that people, if I have a green light and I'm going through an intersection, I value the idea that people are going to stop in the crossroads and I don't have to stop and wonder about it or negotiate with the people as to who goes first and so forth. I like the fact that there's a rule there because it makes society efficient. Rules are good for that reason. We can rely, they don't just restrict us, they restrict others in such a way that society can move forward. So there's really good advantage to having rules and the circumstances like that. I don't want to negotiate at every intersection as to whether and who goes first, even though sometimes I would like to do that. Sometimes I'd like to be able to just go if there's through a red light if there's no other traffic. So I agree with the instinct that rules can be confining because sometimes they are clearly not benefiting increasing utility of everybody. But other times they really do. And those are the times when we value rules. Those are the kinds of rules I think we want to concentrate on initially, where it's very clear that we want people to stop when they've got a red light so that I can go sailing through the intersection. Anyway, so I do think there's cases where rules are right. The problem is rules are not always right. One, again, no cross traffic. Why can't I go through the red light? Two, you mentioned the idea of the government being an issue. Well, there's rules that you and I might just agree to between ourselves. There's no government involved. It's just you and I agree to follow this rule. The problem, the government is kind of red herring because, we think of the big bad government and it's imposing its will on us and we all want to be free and libertarian and so forth. But there are rules that apply even if there's no big government. I think that's kind of a separate issue. And so I really would prefer the idea of focus, or at least I'd like to concentrate on the issue, are rules valuable? Given that they are usually good, but sometimes they're overly confining. What do you think? Are there cases where rules are actually extremely valuable?
Well, the other thing too is especially rules that humans develop for their own human interactions. They can be flexible. Laws that are passed can be very difficult to change. But if you and I establish a game, some rules by which we play, and it turns out they're running into trouble, we can be flexible. That is to say, we can refine our rules. And this is something that's not so common or convenient in legal systems. The rules by which humans live and the rules that law imposes have different characters with respect to flexibility in that respect.
There's an interesting point also, because Michael made it when he was talking about teaching at Stanford and using games as a intro into the way legal systems are rule-based. And I think that's really interesting because you find the game metaphor a lot. You find it with Dworkin, I think, and a couple of other legal theorists. But there's also probably a quite crucial difference. When rules in games and sports are adjudicated, it's very, very rare to find purposive interpretation. We hardly ever ask, what is the purpose of the offside rule? And then decide, oh, given that purpose, this player was offside. And we don't do that. And that is for me a very important difference in the way we treat legal rules from the rules of games. Really, that sets them categorically apart. And there seems to be something interesting that still needs to be unpacked, why that is the case. And it's not with total exceptions. I mean, I've found at least one example where during a chess game, the question was, had the player already touched the piece or not? And it was most often accidental touching. And there was an element of purposive. It tries to prevent a behavior. This accident didn't quite match it, but it's the exception. And I do think there's something interesting going on there. Also then in terms of how we should model these rules and to what an extent we should be taking into account that they play within a framework where we have a shared understanding what its purposes are probably going to be.
Okay, thank you very much. I think that Bob has raised an interesting issue, and then also the other Michael and Burkhard have addressed it. But there is a long, there's been a long a debate going on for a long time in the law concerning the benefits of rules versus standards of deciding issues in advance or at the point where a decision is needed. It seems to me that an important issue for computational law is identify those domains where things can be decided in advance and rules can be made that are not over nor under inclusive. And here there is also the connection with the issue of exceptions that was also mentioned by Michael in his presentation, how to allow for exceptions so that there is a remedy when a rule is over-inclusive. I don't know, I would like to pass this issue also to the speakers, to the participants in the roundtable. I don't know, Bob, do you want to come in?
Well, have I muted myself again? I'm not sure. No, I'm not muted, I don't think. Well, yes, you're so I like the way you've explained it. So it's a question of deciding, making decisions in advance of the need to make those decisions, as opposed to making a decision at the point where it's required. And rules allow us to think through ahead of time how we're going to behave in a variety of similar circumstances. Whereas if you don't employ rules, then you have greater flexibility to arbitrarily, almost at times, make a decision without consult. So, but then when you do that, you typically want to, or if you're being logical, I would say, or analogical, when you make a new decision without rules, you would like to be compatible with other decisions you've made at other times, a form of analogical reasoning without rules. So there's a kind of spectrum between analyzing in advance what kind of issues you're going to encounter, establishing rules for dealing with those issues on the one extreme, and then on the other extreme, not having any rules and deciding case by case what you're going to do, without worrying about being consistent with what you've done on other occasions. And then in between, taking an approach whereby you at least try to adhere to some kind of implicit rule, which means that you make similar decisions in similar cases. And as head of department for that very short period during which I encountered numerous problems and had to retire early. I found, the middle case, being a kind of very useful intermediate position where you're trying to formalize in a sense, your decision making, so that at least you're consistent. You're not necessarily employing rules, but you are. And I guess Michael might call that, the way the common law system works, as opposed to the civil law system that is used in Europe. In fact, that was another topic I wanted to potentially raise. I mean, to what extent are the issues that Michael raised in his talk applicable to civil law in a European context, where analogical reasoning plays and case-based reasoning plays a much smaller role?
Okay, thank you very much, Bob. I think that you also raised the issue of making computable law through case-based reasoning, which is also an interesting aspect, to what extent this can be done. But I would like to give the floor now to Michael.
Yeah, I wish I lived in a civil law system from the professional point of view, because clearly computational law has much more relevance in a civil law system than in a common law system. I have to say that living in a common law system, there are still many rules and regulations which are quite cut and dry. And furthermore, even if we look at the cases in courts, there are often voluminous secondary sources that have digested those cases into de facto rules that we can follow as well. So I don't think it's necessarily inapplicable in a common law setting, though obviously much more applicable in a civil law setting. Such as I'm not really sure there are any really true, pure civil law systems out there. There are many that are much more of civil law than in the United States or the UK. At any rate, so yeah, so I do look to those cases where I would like in the future to be able to bring the adjudication of cases and dealing with common law into focus. But I think right now we have so much work to do in just dealing with the cases of existing hard and fast rules that we have plenty of work ahead of us. I wanted to say something about making of rules. One thing that one theory of lawmaking has it that the legislators and regulators who make the laws have more knowledge available to them at the time that they're making rules and regulations than the individuals do when they're deciding whether or not to obey the rules and regulations. You can't just necessarily always say, well, I'll just ignore this because it's obvious to me that there won't be any harm. Well, there might be harm. And unless you think about what that possible harm would be, the legislators may have thought of that harm. So if you're an optimist and believe that the regulators and the legislators are taking into account knowledge, then it's important. So, I might want to ride my motorcycle without a helmet. How does it hurt anybody but me, right? I'm the only one who's affected by that. If I crash and hurt myself, I'm hurting myself only. Isn't that right? Well, no, not exactly. I mean, the argument goes, well, it's not you, because if I hurt my head, then the medical practice is going to have to take care of me, and they will want to take care of me. And that's going to cost everybody a lot of money and a lot of time. And that's something that the rule was written to take into account that I might not have been thinking about when I was deciding to ride that motorcycle without a helmet. So, there is a reason for people to make up rules and regulations in advance, not only because of the time available and so forth, but that they have a broader perspective. To understand the broader issues of society and who all is being affected by my personal decisions. So I think there's a reason for rules to be made up in advance in some cases, and those are the cases that I was thinking of. Anyway, that's those two comments to your remarks.
Thank you very much, Michael. I'd like to give the floor now to Burkhard.
Yeah, really following up on this, one very quick comment on the civil law, common law divide as someone who moved from one system to the other. I think there's a danger to overemphasize the difference based on some introductory text to comparative law. If it gets to the cold phase, how people actually behave, these differences become much, much less pronounced. And a student of mine did, for instance, a citation analysis of precedents in Austria and in Scotland, England, and the US. And the patterns were remarkably similar, even in the absence of a doctrine of binding precedents. So one has to be careful there, I think. Bob made a really interesting point for me on the exceptions in legal rules, and I think that also speaks to something Michael said. Of course, there's one interesting type of exceptions. They are exceptions that we grant each other because we want to be kind and understanding to each other. All the excuses, all the justifications that we bring in that typically speak to human shortcomings. So if we have a situation like the one Michael describes, where our machines reason about the law, where law becomes ambiguous, they would be the type of exceptions we might not need for that. A car, when making a decision, is not under stress. It's not in fear of its life. It's lots of things that are good reasons to create exceptions fall to the wayside. And at the same time, and I think that's also what Michael just said in terms of the nature of rules, even the rules itself, I think, speak to human limitations and our frailty, our shortcomings. We can't think through all the time, all the conditions, all the circumstances, so we make rules because they are easy. They are a cognitive tool because we are suffering otherwise from cognitive overload. Now, if that's true, if we give ourselves rules because as humans we are frail, limited, and weak, and we in addition make excuses for us that we then put in as exceptions to the rules, then it might not be the case that the rule-based, law-based paradigm really translates well to machines, because they need neither. They don't need our excuses, they don't need our exceptions, but they also might not need the simplification that comes with rules. And Michael gave a very interesting example there, adjusting speed limits really to the driver, to the specific weather conditions, and so on and so forth. So I'm just throwing this in, that there might be something genuinely human about legal systems, a way which we needed to come up with to communicate with each other, but which might simply not translate for that reason particularly well when we try to deal with machines or machines with each other, just as a provocation, if you like.
Thank you very much, Burkhard. So I think that Burkhard's comment goes a bit in a direction that maybe not exactly parallel to what Michael said. That is the idea that machine law would mean bringing the law to the people. So if we are directed by a machine on what we should do, but we cannot really grasp why we are being told what we should do, or what we should do is not something that fits our cognitive mechanism, then there may be a bit a kind of mismatch between computable law and what the law directed to humans. And this also raises the issue of whether the same rules should be directed to machines, for instance, to online trading agents, and to human engaging in the same activity. So I would like to maybe to have a view by our distinguished panelists on this further issue. I don't know if somebody wants to move on. Please, Michael.
Yeah, well, I'd like to respond. It may touch on that, but really to Burkhard's point, that you're absolutely correct. I really like the way you put that for machines, the rules may be less valuable because the machines can do things more rapidly and with more information than a human who's cognitively limited and stressed might be able to do. That's a very interesting perspective. But the one thing that's still in my mind is that whether you're human or whether you're a computer, you're both bound by certain computational limitations. And it may very well be that a rule is defined because of a rather complex, very expensive computation. For example, if I were trying to route traffic to maximize flow from point A to point B, I might say, all right, Bob, you have to go this way. Burkhard, you have to go that way. Mike, you have to go this way. Giovanni, you go that way. And the answer is, well, why does can't the computer figure that out on the spot? Well, maybe a very expensive computation might take seconds or minutes to figure out the optimal route. Whereas having a rule that says if you have a low begin with, if your name begins with Bob, you go left, and if your name begins with Mike, you go right. That might be cheaper But the computers know better, no easier for the computer to figure that out than for a human, because it's a fundamental computational limit. And so there's still a reason for rules. It's not just the fact that computers are, faster and have more access to more data. There might actually be computational reasons to have rules in advance. I don't know. It's just a thought that might save rules.
Thanks, Michael. Bob, please.
Okay, so if you don't use rules, how are you going to what programs will the computers run? I mean, are they going to be neural networks which just use their instincts in order to make decisions? I mean, the kind of programming languages that Michael and I might want to advocate, are rule-based, are rule languages. That they do things, systematically. They don't do things at a whim.
Well, you take a standard and you sort of, you'd run some kind of some kind of neural net, some very, very expensive computation to optimize some utility function. And then everybody acts in accordance with that utility function. But, trying to do that when doing that for everybody would have to communicate with everybody all the time. That would be very expensive. How would the machine in Europe know what the machine in the US is going to do, and maybe those two airplanes have to make sure they fly the same route. So there's cases where I think it's necessary to have some of these decisions made in advance, and but it could be done by, in some sense, having a master optimizer that does that. That's what I'm arguing against. I'm totally with you, but that is the other position that one could take, is that it could always be an optimization step on each optimization computation on each step.
And just to be totally clear, I mean, I'm delighted that the old symbolic manipulation paradigm is so strong here. And I think it's still exactly the right one for AI, a legal AI. So don't take anything I say as a criticism of especially that aspect. I'm very, very happy about that. But one question, for instance, I mean, just to give an answer. Take an artificial society, some of these multi-agent systems, and try to find out what type of rules they would come up with to coordinate their behavior. Just to get this anthropomorphism, it's almost inevitable anthropomorphism out of the equation. What type of rules would a society of robots create for itself? And I still agree with both of you, it still would be rules. They might even be intelligible to us, but they still could be quite significantly different from the type of legal rules in particular that we are used to.
Okay, thank you very much, Burkhard. So I think that seems to me that there is an interesting issue that is emerging, I think, out of our discussion so far. So one issue is to what extent rules for computer systems for automated agents or autonomous agents or digital agents would be similar to the rule that we have for humans. Another issue that has emerged is to what extent legal reasoning should, automated legal reasoning should be limited to what we see basically are deductive or defeasible, but still a kind of reasoning where you have a set of premises and you derive a conclusion according to some mechanism. And to what extent is that computational law should rely on machine learning methods of various kinds, maybe also methods that are compatible with logic programming, such as inductive logic programming. Do you think that there is a role for machine law to go in a way beyond, say, inference, not really deductive or defeasible inference, into some further kind of reasoning or not? Bob?
Well, I'm reminded of the hypothetico-deductive method. The method of science is to hypothesize rules or theories, try them out, and where they go wrong, modify the hypotheses, modify the theory, modify the rules. So, in fact, my view of rules, and ideally legal rules should be capable of the same sort of treatment. Unfortunately, the legal system tends to be rather more rigid. Maybe to some extent, common law systems are less rigid in that respect. But so the kind of rule-based approaches and logic-based approaches that appeal to me are ones which allow, which insist upon evaluating the current set of rules, and where they are inadequate, modifying and improving them. We had an application of a rule-based system for the World Health Organization, which is still running today, written in pure Prolog, which formalized the rules which the working group in the World Health Organization, UNICEF, used to decide the official worldwide statistics about infant immunization, vaccine-induced immunization. And I had anticipated that this approach would be a continual process of formalizing the rules, trying the rules out, and where the rules didn't give intuitively correct results, refining the rules and improving them. It turns out that this didn't work either. It didn't work with the working group, partly because the rules were written in a symbolic notation of Prolog, which was alien to the public health workers who were using the system. That was one reason. And the other reason was that this hypothetical deductive method of continually revising the rules was a bit too onerous. They wanted simply to introduce exceptions. So basically, they set the rules, and after a while they gave up. And whenever the rules didn't give the results they wanted, instead of refining the rules, they introduced an exception. So and I'm not sure this is addressing your question, Giovanni, but in a sense, inductive logic programming, which generates induces rules, is inspired in large part by the hypothetical deductive method. It's not necessarily that closely linked to neural network approaches, but I think when we talk of rule-based systems, I mean, for example, Michael in his planning regulation domain, there's a case where it might be, more feasible to revise rules on a more regular basis, or within an organization. Stanford, when it has its own internal rules, it can actually refine and improve them, and continually do better and better. And this is something that isn't maybe quite as easy to do in a formal legal system. So that's the question: is there a difference between rules in human use, where we're not regimented by governmental institutions, and those that have formal legal standing?
Okay, Michael, please.
Yeah, so I'd like to comment on this as well. Machine learning is very popular right now, and with good reason. It has been exceedingly successful in recent years in a variety of different areas. What I wanted to do is to tease apart two uses of machine learning, though. One of those is for forming theories of the physical world, of the natural world, the naturally occurring world. So, for example, diagnosing cases of breast cancer, or determining what drugs apply, and so forth. Things where we do not have a theory yet, but where we need to do the scientific method to find out what the best way is for describing the way the world is. Something we didn't invent, that we are living within. We don't have an adequate theory yet. Machine learning is exceedingly valuable. It's the basis for natural science. When we switch to the artificial world, where we make things up, it's not clear that necessarily machine learning is the best way to go. So in terms of case-based reasoning, if there's a new regulation, there are no cases that comes down. There's no cases to use to implement that regulation. We need to codify it somehow and directly apply it. We don't have cases to use machine learning on. There's no data to work from, as there is in the physical world. So I'm a big believer in machine learning for natural science. The question is whether or not we should use it to study what happens in the circumstance that to try out new rules. Let's try this rule and see how well it works. Let's try this rule and see how it works. Let's try this rule. In the case where we already have a theory, we can use our brains to figure out what might make a good solution to the problem, rather than just sort of trying things randomly until we find a rule that seems to be adequate. So I'm not a big believer in using it to invent artificial rules. I'm certainly a big believer in using it to invent rules to define the physical world as we perceive it, and then to use those theories to somehow interact with the new world, to control our actions in the world that we've figured out. So that's the first thing: distinction between applying machine learning for one purpose and using machine learning to invent rules. So I'm not a big believer in that. Big believer in machine learning for theorizing about the world.
Yeah.
But there, okay. Oh, sorry. You want to respond to that? I have another point, but I can hold off.
Yeah, I mean, it seems to me that it does indeed become almost necessary if you want to automate certain types of law-compliant behavior. So, for instance, think of a filter system that blocks those and only those Twitter feeds, lines that have a defamatory statement in it. You can't do this with a long list of defamatory statements. If you want to automatize this at all, which I think is probably a bad idea, but that's a different story, then you would need machine learning at that point to learn what counts as defamatory with a certain probability, and then have the rule firing. So that would be the type of interaction, I suppose, you would get between machine learning and a rule-based system in a fully automated environment. And I'm very worried about that. I think there are lots of concerns there, but that would be where I could see the interaction.
Well, thanks.
Yeah, that's an interesting case. I think that's one that straddles the worlds that I was just discussing. I still think that could be divided into how do people react to certain phrases and certain statements, and which is sort of theorizing about the natural world versus it's theorizing about psychology in effect, versus then what rules do we want to have, what legislation do we want to have, what regulations do we want to have is a separate function. Well, okay, but interesting point. That was an interesting example. More of the same. All right, I have a new topic.
Wait, quickly on this, but couldn't you deal with that kind of case by having rules for the clear cases of defamatory Twitter feeds, whatever it was and clear cases which are not? So the two, the positives, the clear cases of positive and negatives could be covered by rules, and then you have this gray area in between where you might use a neural network, or better still use human judgment. So this is the way we worked with the WHO application. We do the clear cases, and where we couldn't figure it out, and then over time, the difficult cases become more and more clear. So you refine, you cover more cases with more positive and negative rules.
I think that's a very plausible initial approach to division of labor, also when to decide how to build the system where we put the human control in. I'm not entirely convinced, purely from a sort of legal theoretical perspective, if hard cases are a property of the rules or a property of a decision by an adjudicator. That is, we look back to a landmark case that decided that a term was ambiguous or problematic. And then looking back, we see, oh, that was a hard case. If you had people ask the night before, they might have said, oh, no, that's totally straightforward. That definitely falls into the rules. So take a case like Stellard, introducing marital rape into Scots law. If you had asked lawyers the night before, how should I code for this rule? Is there an exemption? Oh, yes, of course there is. No ambiguity here. That's a very, very clear rule. Marriage negates accusation, a libel of rape. The court said, oh, no, actually, if you look at this closely, we realize this is a really problematic, ambiguous term. So I think being hard or soft, being ambiguous or not, is at least to a certain extent a post hoc judgment that we only realize when looking back at cases. We can't anticipate necessarily what counts as difficult outside the umbrella, penumbra of doubt, and so on and so forth. We might be able to do it sometimes, but I don't think we can do it always.
Okay, thanks a lot. Please, Michael.
Yeah, I had one other comment I wanted to make here. I'm tempted to continue with this machine learning thing, Ben, and I still think we can divide it in two cases, but I wanted to make a different point. You asked about non-deductive. Are there other things that go beyond deduction? I want to point out that if you're trying to make a rule, you have a standard, you want to accomplish some standard, and you're trying to make a rule that accomplishes that standard, there may not be any single rule which guarantees that standard will be supported. It may work in some cases and not in others. It may be unfair to some people. One rule may be unfair to some people. Another rule is unfair to other people. And we do not know, we can't prove that this rule is best, that some other rule couldn't be better for achieving this standard. And so we need to find some way of inventing rules that we are willing to support as a society, even though we can't guarantee that they achieve our agreed upon standards. So how do we do that? It's not deduction. It's argumentation. Analogy is a great way of doing that. We like to be able to have, we like to simplicity. We like to come up with a simple, elegant theory. Well, that elegance and simplicity, analogy are not deductive, but there are other kinds of reasoning that we need to execute in order to agree upon a set of rules that we will then abide by. And that's why I think analogy and other forms of reasoning are so important in the legal system, is they allow us to agree upon something that we otherwise couldn't necessarily prove must be the case. So there are other forms of reasoning. I'm not talking about machine learning now, although that is another reason that we can base it on statistics. But I think there are other kinds of reasoning that would be involved in the formation of rules and regulations, and that therefore might appear in the adjudication stage, where we've seen a case and we want to say, okay, well, maybe we should have made an exception in this case by analogy to another case or something like that, because we have no way of deciding those situations. And so we decide it's nice. It would be pleasant. It's elegant if you treat these two cases alike. So I do think we need to do that. I don't think we have a good way of we haven't formalized that yet. We have no universally agreed upon theory of doing that. But I think it's essential if we want to start to use computational law, extend computational law to that kind of reasoning.
Okay, thanks. I think that what you are saying, Michael, fits well with what Bob said, that is to have a dimension of computational law that goes into developing, reframing the rules that are to be applied. So we are good, I think, on the application side. We still have to develop this kind of computational support to the creation, adaptation, and making analogy based on the rules that we have. Maybe there is some work on argumentation that goes in this direction. There is the work on case-based reasoning, for instance, by Kevin Ashley and Edwin Arisa, as you mentioned, and others. Do you think that there is a synthesis of this work can be provided? What is your view on these trends of using having computation support this adaptation, invention, modification of rules, rather than the derivation or the application of them, deriving what is implied in them?
Well, if I can just jump in with my quick answer to reiterate something I said in my talk, I actually like separating those more than combining them at this moment, because I think that's the way to make progress. Let's first deal with the case where we have rules and we just want to determine whether or not determine compliance with rules, and to facilitate compliance with rules on the assumption that we have a relief valve of mechanisms beyond compliance checking to deal with these problems. And then separately, have the research community study how we might implement these mechanisms of analogy or argumentation, and to bring them into some kind of a hybrid system. But until we have a solution to that, I think mixing the two prematurely may actually inhibit our progress toward projecting compliance management systems into the world.
Bob, please.
Well, I have worked on argumentation in the past, and was a strong advocate of argumentation, and it has very nice links to both logic programming and rule-based systems in general. And in fact, when I started working with WHO, World Health Organization, my co-worker was very keen to explore, well, to use argumentation. He actually approached me because of my work on argumentation. And because in the application that we were looking at, there were arguments for taking, let's say, an international survey estimate of immunization coverage, but there were also arguments for taking the officially reported coverage as provided by the Ministry of Health for that particular country. So it was very natural to think of making a decision based on how one argument compares with another argument. In the end, that turned out to be not only very difficult to implement, but equivalent, I should say, equivalent to a set of rules which determine which argument won. So once you compare the different arguments in a particular case and then generalize it to other cases that are like it, you end up with a rule and an exception. So basically, we would always take the officially reported statistic provided by the Ministry of Health, unless, this is going back to Michael's point about the magic word unless there were an international survey which gave a contrary estimate, which was wide enough apart to be worth taking instead. If the international survey produced only a small discrepancy, then we would still go with the Ministry of Health estimate. But then we have a counter argument, because sometimes the international survey cannot be trusted. So then we have exceptions on top of exceptions, but these all have an argumentation theoretic analysis. So basically what the rules do is they take these arguments and they generalize them, and they present the result in a form which shows which argument won, which counter arguments were considered, and how did the whole argumentation process play out in the end. So it is possible to give an argumentation theoretic interpretation to rule-based systems. It's possible to incorporate argumentation into rule-based systems, but there's always an element of generalization which you might not get if you only do a case-by-case argument. So that's the big difference with rules. Rules force you, I mean, by their very nature, to generalize, whereas arguments could be just ad hoc and one-off.
Which in a way gives an interesting possibility for what Michael said as well as an application. I mean, also in the chat, there were some references to GDPR, fully automated decision making, and very often we now insist on having meaningful human control over an automated system, whatever that means in detail. And one of the things we know from simply psychology and sociology, it can be very difficult for a low-ranking administrator to overrule the system, to say the computer was wrong, especially if they are on a precarious contract, if they are low in the hierarchy. What does meaningful human control mean here? And one possibility, I think, is what you and Michael in a way both hinted at. It might be able to help that poor guy who's in charge of the system to go to the bosses and say, look, I think we should think again here. This might be just one of these cases where an exception applies, by providing them with possible arguments. Just to sort of, it's easier to go to your boss and say, look, I think there's something fundamentally wrong with what that system just decided, by being able to say, and by the way, here's an argument or an outline of an argument why that might just be the case. That would preserve still the separation that Michael asked for between the two systems, but bring in the benefits maybe that you just described.
Interesting. Thank you very much. I think that I don't know how much time we have for our roundtable, but until I am stopped by the organizers, I would like to move on and ask a question. So if let us assume that we go for Michael's solution, that it's better to distinguish building a rule-based system, possibly including exceptions alongside with rules, and separating such a system for the step where the rules are devised, and maybe argumentation can be helpful at that level. Then argumentation can come back for explaining why an exception has to be introduced in the system. So I think that we have then to distinguish what are the challenges in order to have computational law succeed at the level of rule-based systems. And what are the challenges for having computational law to succeed at this further level, at the level of the choice, adaptation, making hypotheses about rules, introducing new exceptions, and so on. So maybe I would like that the panel gives some their view on what challenges are in these two separate fields.
Okay, could you express them more succinctly now? The first and the second.
The first is what has to be done to have rule-based systems being successfully applied and help people in dealing with legal issues. Right. And the second, what has to be done to have computational tools improve the creation of such rule-based systems. So this would be the two.
Okay, can I come in on the first one then? Because,
yes,
yes. You might be able to predict what I'm going to say, but Michael's already given a hint of that. And I've already suggested that in our work with the World Health Organization, we failed simply because the symbolism of prologue was just couldn't be tolerated. Those in the group who had any knowledge of programming had suffered so much in the process of learning their first programming language. They were not inclined to learn yet another symbolic language. So I've come to the conclusion that what we need is a controlled natural language representation of rules and regulations and laws, which has the additional benefit that it eliminates unnecessary complexity. So when Michael says we can have more complex laws, yes, more complex laws where the complexity is inherent, but now where the complexity is an artifact of the language that you're using to express the rules and regulations. So, in a nutshell, we need tools to if you're going to give power to the people, then they need to be able to know what rules are being applied on their behalf, and they need to be able to read a simplified version of the laws that are being exercised on their behalf. And this is what we're aiming for with what I call logical English, and what other people are similarly aiming for with their own similar controlled natural languages. And there has been an inhibiting factor for take-up in this area, it seems to me. Controlled natural languages have been around for quite a long time, but have had comparatively little take-up, primarily because there's, as far as I know, virtually no online system you can just click a link and start playing with examples, modifying them and implementing your own examples. If you're lucky, you might be able to have the developer of the system allow you to download software, in which case you have to worry about whether your operating systems are compatible and all the rest of it. These systems have to be, very accessible, and online systems are I think the only way that we're going to be able to bring rule-based systems in legal domains to much wider use. And the more close they are to natural language, to plain natural language, to understandable natural language, the better. Anyway, that's what you might have predicted me to say.
Thank you very much, Robert. I think this is very important, and I'm happy to give the floor to Michael, that I'm sure we'll have something to add on that.
So Bob will know what I'm about to say. So Bob just gave a very compelling argument for having a controlled natural language in which to see rules and read. But precisely, he said, it's important. We want power to give power to the people must be able to read the rules. Couldn't agree more. The people must be able to read the rules. He didn't say write. And I think there's an important distinction here between reading controlled in natural language and writing it. One can take Prolog, I believe, and translate it into something like logical English, and thereby make it possible for people to read it, although there are many reasons why you want to use pure Prolog rather than full Prolog. And it still depends on what relations and objects you have chosen to use to express your Prolog rules and whether they have natural versions in controlled English as well. But certainly one can go mechanically in that direction reasonably well and thereby make it possible for people to read such programs. The question is whether or not a controlled language is also an appropriate language for people to write. And there I'm a little more skeptical. Certainly if it's well defined, I have no problem with, and simple enough, I have no problem with writing things in controlled English. I don't care. I don't particularly like ampersands and colon minuses. I'd be happy to say if then and so forth. But the problem is that when you give people a little, they take a lot. When you give them something that looks like natural language, they often will then tend to use all of natural language and tend to become very flexible with the way they express things. And as a result of which they get errors and the system doesn't understand things, or it doesn't interpret it the way they thought it was going to interpret it. And there are these ambiguities that arise because of the fundamental ambiguities of general natural language as opposed to controlled natural language. I think that writing things that way is problematic. And so the only way for that to work, in my opinion, is to have some kind of interactive development environment that can negotiate with the people who are writing these rules to pick apart those ambiguities, to understand what people mean and so forth. Generally, I'm not convinced it's a good solution for codifying rules. I am convinced that logical English or something like it is good for expressing rules. So generation into logical English, I'm 100% behind. Writing things in that form, I'm not as convinced of. Finally, I'll just make one more comment, which is that when specialists do things, they often evolve special purpose languages. Physicists use formulas to write down their physical laws. In fact, they teach them to everybody. That's a very compact, succinct, unambiguous way of saying things. It's useful and so forth. So why not use a specialized language for a specialized purpose, like writing rules in laws? It certainly has advantages for those of us who do know about logic programming. So I kind of like that, but I agree that there's a broader community we need to serve. They need to read these rules, and for that, generation into natural language, into controlled language, is a good idea. I'm still a little bit skeptical in the absence of an IDE. I'm a little skeptical about using it for writing.
I think Giovanni asked a really interesting question. How can we make this more successful? And there's a sort of technologist's answer that I would give. And I would say one of the things that I find increasingly surprising, how little interaction our community had with HCI. Human computing interface design has made such enormous progress over the last years, built on empirical work, trying things out, building artifacts, doing that in a controlled environment. And I don't think we ever really had that culture. So one important thing for me would be to draw more on the experience that we have now in HCI and doing it more empirically as well in the way they are doing. That's my technologist answer. My philosopher answer is, Giovanni, you have asked such an interesting question, but it is really, really difficult and dangerous. Because what does mean success in this case? And for me, one of the big ethical concerns, one of the big worries is that we can make these things successful, not by making the systems better, but by changing our behavior so that the systems can cope with them. And that is, for me, the sort of dangerous feedback mechanism we might have here. And I think it's important to evaluate these systems, not as abstract software, but situated in a social environment, in an organization, in the wild. And I just want to go back to Bob's brilliant national nationality system. There's one clause that I give to my students, still give them when they are trying that thing out, and that said, your nationality might depend on the one of your parents, and I tell them to code for that. And the bad ones simply say, if parent qualifies, then son qualifies. The better ones realize that there is a definition of parent in the definition section that includes adopted parents. Already quite a number of students don't realize that that question at least is solved in a totally different part of the court. And then I tell them, assume the adopted parent adopted the child under a tribal law of a community in Africa that allows polyamorous relations, and the child has 3 mothers. Does she qualify? Does one of them qualify under the Act? For which there's no provision in the Act. So to that extent, we have the usual ambiguity problem here. But in terms of success, now there are 3 things possible. The first one is the computer says no, therefore you don't qualify. So because there is already an answer, and there is an answer, the behavior changes. We now say you do not qualify any longer, and potentially we draw as a conclusion we should organize our family relations in easier ways. The computer doesn't understand that there are more than 2 parents sometimes. Let's not have 2 parents any longer. So that is my worry, hidden under this innocent sounding question of Giovanni. How can we make it more successful? We should make it more successful by making these systems better. We should be very careful that we made them more successful by changing our behavior. If you think of the sentencing system, the problematic compass system, everyone talking about the biased, racist algorithm, that was only possible because we had already designed out discretion in US sentencing, because we had already turned humans into computers. We had given them these really rigorous sentencing guidelines and turned it into a tick-boxing exercise. Turning that into a computer was easy. So that is my worry, that we force success, that we force a match simply by making our behavior more simplistic, more rule-like, but as a consequence losing valuable nuances. So great question, but a dangerous question, I would say.
Thank you very much for all of these considerations. Yes, no, I think following what Burkhard just said, having a more rigid, making the computational law more rigid than human law would possibly have an impact on human relation and human self-understanding, which is not necessarily for the best. We need to preserve that kind of connection between law and values, or law and social situations. I would like now to ask you some questions coming from the floor. Even though I think that there was an issue, maybe before that, there was an issue between Bob and Michael. I would like to know whether Bob agrees with Michael's concern that natural language like writing of rules, formulation of rules may be suitable for the reading of rules, but not for the writing of them. How to connect these 2 phases? I don't know. Well, maybe Bob, do you want something to say on that, or? Well,
Michael was very careful in his final summing up when he said, if you don't have an intelligent development environment, so that's obviously key. You're not going to, you can't expect people to write without, for example, predictive editor, so that what we're proposing at the moment is that you need to declare your predicates, that your vocabulary, you need to, and then use it consistently. And once you've started using a vocabulary, then the system can identify what you're trying to say and help you along the way and prevent you from saying it the wrong way. So I think that will go a long way. But the other thing I think is that it's probably worth trying to teach people how to write more generally better than they do in any case. So in schools today, and in schools in my day when I went to school, we weren't really taught to write in a meaningful way. We were taught to write creatively, imaginatively, entertainingly. We were not taught to write simple things that might be terribly boring, but which needed to be understood unambiguously. So I think that although writing is difficult, there's a kind of writing that is needed for rules and legal texts, which is worth teaching, and independently of whether it's going to be executed by a computer. There's a gap, I would say, in the educational system, and I know Michael's very keen to improve the educational system, and I think I'd like to suggest that maybe teaching better English, French, German, whatever it is, your native language, Italian, of course, that might go a long way to improving rules, regulations, and computational law as well. So I think
Thank you very much.
I think we would eventually agree if we had enough time to go back and forth.
Okay, thank you very much, Bob. So I have some questions from the floor. So the first one is there consensus or not in the panel whether we are close to have computational law applications soon? So I don't know. I think we have already some, so maybe some more. What does the panel think on that?
Well, we have quite a few, and they're growing. There's more and more growing, and I think as the concept becomes more popular, well known, there'll be more demand for this, and the demand will cause more people to create such systems. But the society has to be comfortable with them, and there has to be investment in the creation of those systems, and both commercially, but also within the governmental agencies to accept them, and so forth. There have been some problems with, in the United States, there's has to do with what's called the unauthorized practice of law, where it's officially illegal for a non-lawyer, a non-credentialed lawyer, to offer legal advice. And there is a gray area between what is legal advice and what is legal calculation. So apparently it's always been okay to calculate your taxes, but it's not necessarily okay to do something which may involve some more complex form of reasoning. Generally, if it involves judgment of some sort, then it is considered to be legal advice, and then it's illegal. And so we have to deal with those issues as well of whether it's even legal to field systems that can make legal computations, do legal analysis, and then render that legal analysis to citizens. So we have to deal with that problem. That's getting in the way. But frankly, I think it's already growing, and we're beginning to see more investment in this space. Investment is growing quite nicely. And so I would expect over the coming years, we'll see more and more. It may even become we already see machine readable legislation is on Gartner's list. So the concept might even become more popular.
Great, thanks a lot. I don't know if on this point, maybe we can move on to the further question. We have a question concerning the connection between computable law and the limits to automatic decision-making according to the data protection regulation. This obviously assumes that there is a decision that has been taken, a legal decision that has been taken, not just a legal advice. But I would like to see what's this, if there are any opinions on that.
Well, in a way, I mean, GDPR doesn't prohibit automated decision making. It just gives the subject of automated decision making additional rights, including potentially the right to be exempted from it. But it also gives the right to an explanation. And I think here the type of symbolic approaches that we've discussed today score very, very highly. It's reasonably straightforward from them to generate the type of justification that probably would be GDPR compliant. So I would say, especially for the type of systems that we discussed today, the GDPR problems should be limited.
Okay. Yes, especially I think if the system is going to be applied in the public administration on the basis of some legal background. So in this case,
Yep.
it is one of the exceptions that one of the conditions for the use of automatic decision making according to GDPR. Okay, so let me see whether there is one. I think this is system. Let me see other questions. Okay, there is another question which concerns whether lawyers and computer scientists have a different perspectives toward computational law. I don't know. Burkhard, you are also no, you're I'm the only lawyer. So you are the computer scientist. What do you think of that? I think that lawyers, you can find lawyers as quite a mixed bag. Now there is generally a lot of enthusiasm towards any kind of automation, machine learning, or of any other kind on the lawyer side. So I think that computer scientists have the time. Now, in the past, lawyers used to be skeptical. Now, computer scientists has to confront the excessive enthusiasm, I think, of lawyers.
I think it would be interesting to do some more really hard psychological cognitive science research on this. I can only rely on anecdotes, but one of the things that often happens in my courses where we have lawyers and computer scientists next to each other is that typically the computer scientists start to explain the law to the lawyers, and the lawyers start to explain computing to the computer scientists. And that is not always particularly helpful. Where I think the greatest difference is, and that changes over time, and I really would like to study this more, is very often the computer scientists start with the assumption the lawyers can give us the answer. And they get really, really frustrated when lawyers don't give the answer. You know, it depends. It could be argued like that. There is a claim to be made, this hedging, that causes quite a lot of friction when they first work together. And that then changes over time as they get used to their vocabulary. But that would be, for me, at least when they get newly to interact, would be the greatest source of difference in thinking, I would say.
Thank you very much, Burkhard. I think we have gone to the last. We have a last question that I find interesting, so I will go a bit beyond the time. I think also short answers will be okay. The issue is, what is the connection between AI and computational law? Are we doing AI when doing computational law, or are we doing something different? I think this is an interesting question, because now AI is so fashionable. So I would like to see what is the opinion of the panel on this issue.
I would, in order to comment, I'd like to ask you or the questioner, what is AI? I mean, the problem is that AI has become synonymous in many circles with machine learning. And so the question could be reduced to, does machine learning have anything to do with computational law? If one looks at AI more broadly to include symbolic reasoning, knowledge representation, then certainly all the kinds of things that Bob has worked on and that I was talking about are part and parcel of AI. And so obviously there's a huge overlap. So I'm not quite sure whether the question concerns the relationship of machine learning to computational law, or whether it has a broader version of what AI means.
And I think that your analysis of AI give already a kind of answer to this question, but I don't know if Bob has something to say or Burkhard on this point.
Seriously, I totally agree with Michael. Of course, some good old-fashioned AI is still AI. This is just part and parcel of AI. The slightly more cynical in me would define AI as that type of human cognitive process that current computer science just can't solve yet, but might solve in 2 years' time. So no one has ever been doing AI. AI is always a promise of things to come yet. And in that sense, either yes, it is already AI, or it will never be AI, are both acceptable answers.
I like that answer.
And Bob, I would like to have also your opinion, since you have been working on AI for I don't know how many years now. But,
right. Well,
on legal reasoning.
Okay, I'll address this question by going back to the previous question at the same time. The difference between lawyers and an AI or computer scientist when it comes to legal issues. I once got into trouble by writing a paper which was then paraphrased as saying, if you want to do computing, you should be a lawyer rather than a programmer. And that was based on my experience of analyzing and working on the British Nationality Act, because the British Nationality Act is written so beautifully, so precisely, so perfectly, that I would challenge any normal computer scientist to write a program specification that was anywhere near as clear, as precise, and as beautiful as the British Nationality Act. So that's computer science. So I would say that the top flight lawyer is a better computer scientist than the standard. So I got into a lot of trouble, and I know I'll get into trouble again by simply repeating that. But the other point to make about law is that it has very wide coverage. Law, can enter every field of life. So in a way, law is a paradigm for artificial intelligence, because it to some extent regulates human behavior in all aspects. So in a way, if you take a very high level view of automation, to some extent, rules in law automate and regulate human affairs, the human machine. So I would say there's a true family resemblance between law, at least some approaches to law, and artificial intelligence, because they both automate and regulate behavior. But law is very wide coverage. It deals with all aspects of human life, all aspects of knowledge representation. So I think there's a very good marriage that can be made between these two fields.
Okay, great. So I think we have gone a bit beyond our time, but I think it was worth doing it. I would like to thank very much our three great participants, Bob, Michael, and Burkhard, for their contribution. And I'm sure also the audience enjoyed our chats. So thanks to everybody. And I don't know if the organizer have something to say at the end of this meeting. I would like to give the floor to Hans-Georg, maybe at this point. And thanks again to everybody. Excellent.
Hey, thank you very much to our panelists. Thank you very much to Professor Sartor for chairing this session. I think it was an excellent discussion that we heard today.